Can we zoom in? Hello, hello. Yeah, all good. Good evening, everyone. Good evening, Shillong. Good evening, Itanagar, Tamenglong. Welcome to the class, and I hope you all good. Thank you, Tetsu. Thank you, and a very good evening to all of you. First of all, and I think maths class is being held after almost 2 or 3 weeks, right? Okay. So tell me, how are you guys, all of you? Shillong, can you tell me what is your attendance? Shillong, Tamenglong, Itanagar, all of you, please share your attendance. And also, if you have any camera, then share your port number as well. Okay? 6. Thank you. Shillong, can you say your port number? There must be some camera in your classroom, right? You should check, please. Well, this is not afternoon, everyone. This is evening, right? Okay. Itanagar is present. How many kids are there in Itanagar? How many? Seven. Tamenglong is 7. Okay. That's great. So why this is 7 out of 12, Tamenglong? Is there any particular reason? Or they have dropped? They have dropped out. What is the reason exactly? Like in the maths only they are coming 7, or in each and every subject they are like 7 to 8? We will start in 2 minutes, don't worry. So as I'm coming after 2 or 3 weeks, so let me make sure all of you are fine. So is there any doubt, anyone? In the previous chapter, quadrilateral, and I have shared one assignment on quadrilateral, so I'll definitely would like to tell you the solutions, but when I'll get the queries. I have got some queries from Mode 1, so, but that is only one student, so I'll do it separately or over the WhatsApp. I'll not discuss in the class, right? Okay. Itanagar, they have 8. Thank you. So thank you everyone for your responses. Okay. What about Shillong? Do they have any camera? Shillong. What is exactly a promotion exam? Tamenglong. I'm not getting it. Promotion exam means? So will you guys get promoted to some other section or the next standard? Because that is not possible without completing a year, entire year, right? So what exactly this term means, promotion exam? Okay, okay. So that is basically final exam, right? Okay. But final exam is like, this is October, right? Final exam should be in the month of February or March. Isn't too fast? Or okay, everyone. Okay, okay then. November, right. So let's start the next chapter now. November, seriously, everyone, okay, okay. So have you completed the syllabus, entire syllabus, all of you? because most of you are having final exam in the November, and like we have completed all the initial 8 chapters we have finished, and after that we have completed the chapter called Heron's formula, right? Surface areas and volumes that we have covered, probability we have also covered, right? We're only left with, I would say, 2 chapters, right? One is circle and second is statistics. Is that clear? So tell me after this class, right, which is on areas of quadrilaterals and triangles, which chapter you want me to start next? Is it circle or statistics? Okay, so on that note, I'll start now. Okay. Areas of quadrilaterals and triangles. Hello Prashant, how are you? Areas of quadrilaterals and triangles. So areas of quadrilaterals, in this particular segment we will study about the figures or about the areas of those figures which are lying between the same parallels and their base are same. Okay, we'll talk about same base figures which are made on same base and lying between the same parallels, between the same or lying between the same parallels. Okay, welcome. So this is we are going to deal with all of, right? So let's start with some of the basic theorems. I'm not going to prove all the theorems because you guys know how to prove them, but I'll give you the results directly and we will use them, right? We will use the application of all the theorems one by one. So let's start with the very first theorem, number 1. It says a diagonal of parallelograms divides it into two equal areas. First one. Second is parallelogram on the same base and between the same parallel, that is, they will have equal at altitude. Is that clear? Equal altitude are equal in area. We will also do some question which will be based on proof, but theorem we will not prove. Okay, we will use these theorems to prove the examples and to find out the different datas of areas, right? Third is the area of a parallelogram is equal to the area of the area of a parallelogram is equal to the area of a rectangle on the same base and of the same altitude. Is that clear? So what we are saying actually, let me show you this one, because first and second we know it clearly, right? Basically, if you take some parallelogram, let me take some parallelogram. And if you were to draw a diagonal, so of course, this area and this area will be equal, right? These two will be equal. Parallelogram on the same base and between the same parallels, that is equal altitude, are equal in area. So definitely if this is suppose the base and we have these one parallelogram and the other parallelogram we can consider like this, somewhat like this. So these two will be same. These areas would be same. Both areas A and A will be same. Is that clear? Third is very much important because most of the question you can solve using this concept of rectangle, right? Because area of rectangle and square, you can always find out very easily. So this is the area of a parallelogram is equal to the area of a rectangle on the same base and of the same altitude. So if this is your rectangle, let's say this is the parallelogram, I were to say parallelogram. What is area of this parallelogram? So you have to find the area of this parallelogram. Equivalently, you can find out the area of the rectangle made on the same base and between the same parallel, or I were to say the same altitude, right? So here area of parallelogram ABCD, it would be same as ABEF. No, it's not half. That is area of triangle. I'll tell you how's that. ABCD. This will be same as area of rectangle ABEF. Right? What is the area? Let's say this is X and this is, let's say, H. So both will be same, X into H, and this is also X into H. Is that clear? Point number 4, it's regarding the triangle. Triangles on the same base and between the same parallels have equal areas. What does that mean? Can I show you some figure? Yes, definitely. You see, this is, let's say, the base. I'm taking this as the base. Now I can take so many cases of a triangle. Let's say I'll be restricting this to the maximum height of this one. Now let me take this triangle, right? This triangle, or I can take this triangle, or I can take this triangle, right? Or any of these. Areas of all the triangles are same. Is it clear to all of you? Areas of all the triangles are same. Why? Because triangles on the same base and between the same parallels. If this is one parallel, this is the second other parallel, and the common base we can consider, right? So in all the cases, area of all these so formed triangle would be same. Next point, fifth one. If a triangle and a parallelogram are on the same base, and between the same parallel, the same parallels, the area of the triangle is equal to half that of the parallelogram. So these are all, most important theorems, I would say. Well, yes, I am getting some queries regarding, sir, will you prove any of these? Yes, definitely. If you want me to prove, I'll do that. But as in my concern, there is nothing to prove about these theorems, right? They are well defined. You see, talking about point number 4, triangles on the same base and between the same parallels, their area would be same. It has to be, right? Because ultimately, what is the areas of any of the triangle? Right? It would be area of any triangle. Any triangle would be nothing but half of base, which is same for each and every case, right? And its height. Now, what is height actually, guys? Height is nothing but same. You see, in all the cases, height would be this length, right? Let's say this is x and this is h. So in all the cases, it is half into x into h. There is nothing to prove on this, right? Wherever required, I'll definitely would like to tell you the proofs. And we will also do some examples which will be proving actually, using all these theorems. Prashant, is it okay? Because see, there is nothing to prove about this, right? But yes, this is important. I would like to prove this one, the last one, fifth. So let's prove this one. First of all, what should be the diagram for this, right? The diagram is something like this. Let's see, this is the base of a parallelogram. A, B, C, D. If a triangle and a parallelogram rise on the same base, okay, same base. So next is, I would like to take one triangle also. Let me take this triangle. I'll take from the diagonal actually, which is most in general. Is that clear? So here, can you tell me what is the area of parallelogram? Area of parallelogram. What is construction? You see, construction is draw perpendiculars, draw perpendiculars DM and CN. Right? Draw perpendicular DM and CN. What to prove? To prove that we want to prove that area of triangle ABD will be half of area of parallelogram ABCD. Right? This is what we have to prove. So start proving now. Here, ABCD is a parallelogram and BD is one of its diagonal, right? What is the area of any parallelogram? Area of parallelogram ABCD would be base, which is AB, times DM. Let's take, see, DM and CN both are same, right? So I want to take DM, AB into DM. Similarly, area of triangle area of triangle ABD. What is area of triangle ABD? Area of any triangle is, what is ABD triangle? This is ABD triangle. A, B, D. This is what we have drawn as DM, perpendicular, right? So area of this triangle would be half of AB into what? DM. This is 1, this is 2. Clearly, from 1 and 2, area of triangle ABD would be half of area of parallelogram ABCD. As proved. Also, you can prove it in the other manner, because we have just understood in the very first theorem, you see, that a diagonal of parallelogram divides it into two equal halves, right? Into two equal areas. So that is also valid here, right? So using that also you can prove. If this is, suppose, area of ABD triangle, which is say X, right? And this is some other X, because both are the areas are same. So if this is 1X, other X, total is 2X. So basically, do not need to take X or X anything, right? It is very obvious that if these two areas are same, so complete area would be the double of any of these area, which is the area of a triangle. See, I'll repeat it one more time, everyone. Please listen it carefully. Okay? ABCD is a parallelogram and BD is its one of the diagonal. Okay? Now, can you tell me what is the area of any parallelogram ABCD here in this case? You see, area of any parallelogram is always base into height, right? What is base? Base is, let's take AB as the base. What is the height? DM or CN, both are same. So any of this you can take. I'm taking DM. Is this AB into DM? Is that clear? Now again, what is the area of any triangle? Area of any triangle is half into base into height. So what is the area of this triangle? ABD. What about ABD? See, this is ABD, right? ABD. So what will be its area? Area is always half base, which is AB. Is that true? Yes, half of AB into DM, right? DM, height. Height is nothing but DM. So this is what we get, half of AB into DM. Now clearly from 1 and 2, area of ABD is nothing but half of, see, these two are same thing, na, basically, right? AB into DM is nothing but area of parallelogram. So if I were to say half of, this is what completely? Completely it is area of parallelogram, ABCD, right? So area of this triangle would be half of area of parallelogram ABCD. Is that true? Have you understood, everyone? See, these are not, I would say, theorems. Actually, these are simple points, right? Which is, while writing, they seems to be very obvious. Last part, okay, last part. This is what triangle ABD, right? Area of triangle ABD, okay? So what we are writing, half of AD into DM. Now can you tell me what is this quantity, AB into DM? This is so simple. If I were to say, let's say, area of this ABCD is AB into DM, I'm writing, right? Area of triangle, I'm writing half of AB into DM. Now what is AB into DM? AB into DM is itself area of this parallelogram from here, right? Okay, if you're not good at it, let me do it again. Don't worry. Totally fine. Now you see, dividing 1 upon 2, right? Equation number 1 and 2. So what do you get? You will get area of parallelogram ABCD upon area of triangle ABD equals to, what do you get here? You will get AB into DM divide by half AB into DM. Now these two will cancel each other, right? So what we can write, area of triangle ABD would be, now you see this is what, half of this, right? We'll cross multiply, so this is half of area of parallelogram ABCD. Now is it good? You understood? Everyone, please tell me if you understood. Is it clear, everyone? Say yes or no. Yes, very good. What about Tamenglong? Have you understood? Question is, very good. Prove that prove that area of a trapezium is half of the product of its height, and some of the parallel sides. Is that clear? Prove that area of a trapezium is half of the product of its height and some of the parallel side, right? So we can construct a trapezium. What is trapezium? How does it look like? It will be something like this. There will be two sides, right? This is a trapezium. Let's say AB, and this is CD. Always remember it should be in order A, B, C, D, right? Now what we are taking is, this is not necessarily to be perpendicular exactly. Okay. Now this is any in general trapezium. Now what we will do is, we can draw this perpendicular. Right? So what we have to prove, you see, to prove that area of ABCD, quadrilateral or trapezium ABCD, is, it will be how much? Half of, we are saying half of the product of its height. Let me take height as h. This is, we are taking as h. And this is what? Let's say A, and this is B. Okay, this is A and this is B. What this point is, let's say M. Is this clear to all of you? Say yes or no. So far what we have constructed, what we have defined to prove the result, to desired result, half of A plus B into H. This is what we have to prove. Right? Area of quadrilateral or trapezium ABCD would be half of the sum of parallel side, which is half of A plus B into height, product of its height and sum of the parallel side, right? This is what we have to prove. To prove this, what we will do is construction. Construction is draw AC, right? So what we will do is, we will meet these AC now, this point A and C. Okay, focus on this. A, B, C, D. This you have to prove, right? A, B, C, D. This area you have to find out. Right? What is this area actually? Area of trapezium ABCD equals to it will be, see, this is the total area we have to prove for, right? A, B, C, D. Now, There are so many ways to write this area, right, as the summation of two other areas or two or three, I would say, right? But the most easiest I can see is if I were to write for ACD, area of triangle, AC, area of triangle ACD, right guys, and area of this triangle which is ABC. Is this clear? Yes, makes sense. Next. Now what is the area of triangle ACD? What is triangle ACD? ACD, right? So what is the base? Base is DC. What is the length of this base? Length of this base is B, right? So half of base, which is B, into what is height? Height is AN, which is also CM, which is given as H. So that is H. This is the area of triangle ACD. Now next is area of triangle ABC, right? What is the area of triangle ABC? Half into base into height. Can you solve this? Very easy. Half of, you can take H common and we are left with A plus B in the other bracket. And is this what we are supposed to prove? Yes. Half of A plus B into H. Hence proved. This kind of easy proof you can expect in the exam. Is that clear, everyone? Okay, so let's do some questions now. So this is, you can consider as a question, or I would say you have to remember this, right? Whenever you find a trapezium and you have to find the area of such trapezium, that area would always be half of product of the height and sum of the parallels, sum of the bases. Any doubt, anyone? Tell me if you have any doubt. We have broken this complete area into this area, right, and into this area. No doubt. Very good. Right, this was the actual case. Anyway, next is, let's do some question now. Question is, so that a median of a triangle divides it into two triangles of equal areas. Triangles of equal areas. This you have to prove. So that a median of a triangle divides it into two triangles of equal areas. Okay, this is you have to prove. Take your time and try to prove this particular, where we have to draw a median. So we can consider any general triangle, something like this. This is A, B, C, A, B, C. And there's a median given. What is median? Median is let me take this A point and we will draw a median onto this BC side. So this is nothing but median. Median means BD equals to CD. What we are given with? BD equals to CD in triangle ABC, AD is a median. That is BD equals to CD, right? What we have to prove? To prove that area of triangle ABD is equal to area of triangle ADC. This you have to prove. Right? Now, as you can see, both of these triangle, whether ABD or ADC, both are lying between the same parallels. How? Let me show you this also. If this is one triangle, this is nothing but A, this is your ABD, right? On the same level. Right? We can assume this another triangle which is this one, DCA, right? What is the height? If you have to consider height, that will be same for both the triangle, and that is, let's take H. AAS theorem. No, there is no AAS theorem. There is no AAS theorem, dear. Right? This is not you have to prove similar triangle, right? That is not the case, probably, right? You have to prove areas are equal. We are not saying that these two triangles will be congruent or similar. No, that is not the case. It can be any scalene triangle of any length, right? So we cannot say that we have to prove symmetry, or I would say symmetric or maybe congruent. But this is the case. We have to find out the areas, and if their areas are equal, then this is what we were supposed to prove. Let's prove now. What is the area of? Can you write down the area expression for ABD? It would be half of BD into H. Right? BD into H. Similarly, what is the area of triangle ADC? That would be again half into DC into H. Because if lying between the same parallel, so that would be H and H in both the cases. As BD equals to DC, so area of triangle ADC we can write as half BD itself. We can write it as BD, right? BD into H. Now from 1 and 2, I were to say this is 2. So guys, what we can conclude is, from equation 1 and equation 2, we get area of triangle ABD equals to area of triangle ADC. Hence proved. Coming along, did you understand what was I want to tell? We cannot prove this by AAS, right? This is not, we have to prove whether two triangles are similar or congruent. No, we have to prove the areas. Their areas are equal. So we have to totally work on areas thing, right? Of course, if two triangles, see what I'm saying is, you have to understand, right? This is what I'm trying to convey. You have to understand. If I'm saying that congruent triangles congruent triangles will have same areas? Yes, definitely, right? But converse is not true. I cannot say that same areas, if two areas are same, we are taking two triangles and their areas are same. So we cannot conclude that they are congruent. No, that is not the case. No, that is not true. I mean, two areas are just for the data part, right? If data are somehow, you are getting the same numbers. Areas, you are getting the same numbers. Did you get my point? First of all, there is no symmetry. They are not congruent. First of all, what you was thinking, what you guys were thinking, that is not correct. Right? Because they are not congruent triangles. They are two simple triangles, right? Yes, of course, there is one specification about that is that they are having a median. And what a median does basically, median divide any face or the corresponding side into two equal halves. Okay, then you prove it, please. You prove it, and I would like to know that actually. That would be something I would learn from you, right? I totally welcome all of you. So you tell me how would we prove with AAS? I mean, AAS is not, I would say, is not the incorrect one, but these two are not congruent, first of all. They are not congruent at all, right? Datas are would be in such a manner that their areas would be same. Then that number, area for the number would be same. I mean, number for the areas would be same. You try to prove it and tell me how is it applicable AAS. Yes, definitely I would like to show you the figure. This is the figure. Now, how these are congruent, I'm not getting. How these are congruent. Okay. You must know what is actually congruency, right? Let me take this triangle. Now we are saying that this is the median. So let's take this as the median. Anybody can tell you, no, what is this point? C, and this is D. Anybody can tell you that ABD is not congruent to triangle ADC or whatever ACD, I mean. Anybody can, justify that ABD is not congruent to ADC here. Because congruency is something this. They have to be same. They are not identical at all. You're getting my point? See, this is very important. Congruent triangles will definitely have the same areas, but converse is not true. If you are saying that same areas are given, then the only possibility is they are congruent. No, that is not the case. I'll give you an example of, let's take a triangle which has base and height as 6 and 4. Right? This is the base and this is the height. Guys, attention, okay? This is 4 and 6. What will be the area? Area is half into 4 into 6. That is how much? 6 into 4. This is 12, right? This is 12. Now, if I were to take some other base and height, let me take this base as 3 and height I would take as how much? 8. Then what is the area? Again half into 3 into 8. This is again 12. So they are having same areas. Are these two congruent? Seriously? 4 and 6, 3 and 8, are they congruent? No, They are not congruent. Definitely they are not congruent. Right? I don't know which part is actually bothering you. Who said this to you that we can prove this via AAS? Right? You take your time, don't worry, don't worry. You take your time, and when you are satisfied, then only I'll move again. Okay? You please tell me, do you think, again I'm asking you, do you still think that these two are congruent? Or we can prove via congruency? Tell me. Are you sure? Are you sure? I mean, it is not like I'm forcing you to accept the fact. No. You figure it out, you analyze it totally, and then come to a conclusion that, okay, sir, these two triangles cannot be congruent, or what I am trying to convey is that if areas are same, there are so many possibilities. One of the possibilities they can be congruent, right? So that is one of the possibility out of so many infinite possibilities. Areas are always areas of any triangle or any geometry depend on the data, right? If you can vary the numbers, like if 8 into 3, 8 into 4, 32. 16 into 2 is also 32. You can take any other pair of numbers which will give you again 32. You getting my point? Everyone, please reply. So, is this clear? Tamenglong and Kangpongki. And please, I need reply from other center also, because Silong is silent for a while. So, Silong, am I right? I'm of course right, but still, I need, what do I say, boats or something like dissent, Silong, Itanagar, it's a yes. Okay, thank you, Itanagar, for supporting me. What about Silong? We have discussed so much on this, but it is good. I don't know what exactly you were trying to convey with this AAS. Is that clear, everyone? Thank you, thank you. Thank you, Silong, Itanagar, and all the others. Okay, so that is your homework, I would say. Kangpongki, right? Prove that area of a parallelogram is base into height. That is your proof. Okay? You should work on this. I think that. You guys should try on your own. Right? If you're not getting it, definitely I would like to tell you in the next class. Right? Is that clear? Or if you want me to prove, then I have to prove. No, I have no other choice. But did you bring Lee's test paper? Which test paper exactly? Which is being conducted in the last week? Is that for triangles? I guess, right? It was for triangles. I remember. Last week, okay. Yeah, I have discussed all the papers before triangles. The reason I'm not discussing today, because this class has been happening for like after almost 20 days, right? I remember 15 to 20 days. So that is the reason I have to cover some, chapters, some solid chapters. Of course, I'll do two things. Either I'll record a separate video for the solution of triangles, or if in the next class I'll discuss. Is that okay? No, I don't carry right now. Question number 15. Tamanglong, I request whoever the student is, please remind me on the WhatsApp. Okay? So I'm really happy that you guys are serious about the discussion. But if there is only one or two kids, better would be if you ask me on the WhatsApp, right? I'll send you the solution. And even I have to send you solution for this last assignment which I have shared with all of you. Okay? Is that clear? You please remind me, Tamanglong, I hope you're understanding my point, because everybody is not that serious. Don't take it otherwise, but like everybody is serious. But I mean to say is that if there is only one or two kids in any of the center who want me to do something, so better to do on the group, right? So if I'm getting some query in masses, then I'll take that discussion into the class. Because you are also having exam in November. So how would I supposed to finish the syllabus? It will take time, na? We have to finish almost two to three chapters. Okay. No, I'm not saying. You are always serious. Don't worry. Yes, Etanagar we have covered Heroes Formula chapter. So you again can remind me on the WhatsApp. I'll share the link with you, with all of you, so you can access those videos from there. And if you find any difficulty to understand, you can ask me. Is that clear? Next question is, let's do this question. Please remind me, all of you, please remind me, once again I'm telling you, right? If there are some individual doubts, you can ask me on the WhatsApp, right? Today I'll be there for you, all of you, right? For 9th class especially I'll be there. So all of you, starting from the assignment solution, the link access, or the paper discussion, any of this, you just remind me. I'll tell you the solution. I'll share the solution with all of you. Okay. Thank you. Next question is, thank you, Tamanglong. Next question is, okay, no issues. I'll definitely do revision of all the classes, right, of all the chapters. So definitely we will take Heroes Formula as well. But remind me in the WhatsApp, okay? Question is, ABC is a triangle. ABC is a triangle in which D is the midpoint, of BC, side BC, and E is the midpoint of, we have to prove that area of triangle BED equals to 1/4 area of complete triangle ABC. This you have to prove. My question is to you. My question to you is area, right? There is a complete triangle ABC. No, that is not the case. That is not the case, Kangpongki. Yes, you start solving, all of you. You please draw a triangle and do as question is demanding. And then I'll tell you if you're not able to solve it. Meanwhile, Kangpongki, yes. Kangpongki point is very, I agree on that. That is really correct. Kangpongki is saying that the question I do in the class and the homework They are totally contrasting. Yeah, that is true. I would not say like this is somehow what I am doing in the class that is totally different from the homework part. No, that is not the case. In the class, we do all kind of. I'll try to cover all the kind of all the categories, types of the problems, but there are still some problems which needs to be covered, which you have to solve, right? So when you attempt, or those who are really serious, because these problems are not those easy, I would say, right? So those who are really attempting all the assignment, all the questions which I am providing as the part of homework, so if they find it difficult, I'll definitely tell you how to solve them, right? The reason I'm not taking all the categories or I skip, right? Yeah, I know that I skipped some of two or three challenging problem or the tougher problem, I would say, right? Because I have to see each and every kid in the class, right? So starting from easy to average to moderate, easy to moderate to tough, I have to cover, right? And in the homework, if you find that, okay, two or three problems are different, they are totally contrasting, then you can ask me. So those who are actually attempting, they will get to know how to solve them. Is that clear? So this is not like what I'm doing in the class is totally contrasting from the homework. Or you can also say, sir, what you are asking in the exam, that is totally different. That happens. It is how, you know, uh, this system goes on, right? This education goes on. If I do all the things in the class, then there is nothing left in the school, I would say, for your homework, sorry, not the school, for the homework. But if I cover all the things in the class and homework, then all of you would score 100% in the exam, right? That doesn't make any sense. There should be something which only some of you will be able to solve. I hope you're getting my point. Of course, now this is break time. We are talking for so long. I need also a break. Okay. I also need a break now. So let's take a break, and after 10 minutes we will start. Hello, hello. So is everyone back? All right. Please respond something if you are back. Okay, let them come, let them come. Let me draw the diagram till then. ABC is a triangle. ABC is a triangle in which D is the midpoint of BC and E is the midpoint of AD, right? And please, all of you should come at the time, right? Okay, all right, they are back. All right. So I hope that everybody is back now, right? Because this is almost 10, 11 minutes. And there is nothing you cannot do in 10, 11 minutes, right? So it makes sense. ABC is a triangle in which D is the midpoint of BC and E is the midpoint of AD. So let's write down one by one. BC. D is the midpoint of BC. All right. So let's take this as some triangle ABC. ABC. There is point D. Okay, they will come. Don't worry. Don't worry. A, B, C. This is D, right? D is the midpoint. Okay. No issues, Itanagar. Take your time. D is the midpoint of BC and E is the midpoint of AD. So now we have that E is the midpoint of AD. And if we meet BED, so this is what we got, right? E point. Now we have these two are also equal. This is all about the question. Is that clear? E point. This is the diagram, right? Now, if BD is the midpoint, I mean D is the midpoint and BD equals to CD, then definitely since AD is a median, that is BD equals to CD. Also, area of triangle ABD would be equals to area of triangle ADC, right? ADC. Means these two areas are equal. This is equation number 1. Now, in triangle, this is in triangle ABC. Now, in triangle ABD, we have BE as the median. BE is the median. If not D, BE, right? BE is the median, then bachcho, what we can conclude is that AE equals to ED. Also, that area of triangle ABE will again get distributed, because see, if this is the case, let me show you in this other diagram, the separate diagram. You are saying that if this is a median, then how a median would work, you see. Right? So if this is your point A, this is B, this is D, this is E. So can you tell me if these two bases are same, between the same parallel, these two areas will also be equal? Yes, because again, See, if there is a median and it distribute, I mean, if any median is there in a triangle, that will divide into two equal areas, right? So again, we can write that area of triangle ABE, this area would be nothing but half of which area? Half of, or let me write first, half of area of triangle ABD. Is that clear? Here, area of triangle ABD is actually half of area of complete area ABC. This is important, right? Area of triangle ABD would be half of triangle ABC, as these two areas are equal. So any of half will be total by 2, right? Total by 2. Total is ABC by 2. Similarly, if you were to solve for this segment, area of triangle ABE, that would be half of this complete triangle ABD. Is that clear? Right? So this is, let's say, equation number 1. This is, let's say, equation number 1. From equation number 1, what we can have is area of triangle ABE, you can write as half of. What is area of triangle ABD from 1? Half of area of triangle ABC, which is how much? 1 by 4 area of triangle ABC. And that is what we were supposed to prove. We have to prove that BED, or you can take ABE, not an issue, BDE. BDE is also BDE, hence proved. Basically, both the halves are equal, na? So proving any one is similar to prove the other one. So does the median of triangle equal to each other? Medians are not equal to each other. Scroll up. Of course, I'll scroll up. What is your doubt exactly, Tamenglong? I'm not getting. One more time, can you repeat it? Areas divided by a median, they will be equal. Right? Say yes, everyone, if you have completed, if you have understood it, else no. So I'll repeat it, please. Now this is enough of proof. We have done like 2 or 3 proofs we have done. Now we will take some numerical question which you have to find the areas in numbers, right? Silong, can you raise your hands? Okay, please write it, not an issue. Take your time. Shillong, can you say your port number? Shillong. Have you completed, all of you? Are you done with the copy part? The writing part, please let me know. Next question is, I hope that you have finished it now. Question is, in the figure, okay, let it be, don't worry. You please solve this question. In the figure, it's okay, Shillong. In the figure, find the area of quadrilateral ABCD. Diagram is this one. There is this base given. This is given 90. This is A, B, point C, point D. Lengths are given 9 centimeter. This is 8 centimeter. This is 17 centimeter. You have to find out the area of this quadrilateral ABCD. This is given 90 degree. This is also 90 degree. Which question exactly? Itanagar? This one? No, this is basically half of area of triangle ABD, right? Try to understand area of triangle ABD. Now what we were supposed to prove? We have to establish a relation between area of triangle BDE and area of triangle ABC. Right? So now how you would invoke this ABC triangle? See, there is a relation between ABC and ABD and also between BD and ABD. ABD is the common one, right? No, that is not the case. Itanagar, have you understood? So once you will establish this relation between ABD and ABC, right? This half and complete triangle, and then you will take this half and this triangle, right? So what we can write? Half of triangle ABD. Okay, now what is triangle ABD actually? If we were to suppose we were supposed to prove this, then this is the answer. But no, we have to prove BD and something with ABC. Right? Sorry. So if this is area of ABD, then what is area of ABD? Area of ABD is half of area of ABC, right? So that is the reason I have plugged in the value of area of ABD in terms of area ABC. Still any doubt? Itanagar? Okay, now coming to this point, this question. So all clear? We are good? Area of complete quadrilateral ABCD would be area of triangle ABD plus area of right angle triangle, not only triangle but right angle triangle BAD. I can write BAD. Area of triangle CBD, right? Always put, when you are actually specifying that triangle is a right angle triangle, so you have to take the right angle vertex at the medium position, right? The middle position, not the medium, middle position, right? Is that clear? Now, triangle BAD. Now this is triangle BAD. So what you have to do is half of AB into AD, right? Half base into height plus again half into CBD, right? This is CBD, so it will be again BC into what is its perpendicular or the height, that is BD. So this is BD. Now let's plug in all the values which is already given to us. So half of AB, we do not know what is AB. Do we know AD? Yes, that is given 9, so this is 9 plus half of what is BC? BC is given 8, but BD is not given. Okay, so far we need two values now, right? AB, we need value of AB and BD. Let's come to the figure now. In the figure, if this is a right angle triangle, so what is distance BD? BD would be square root of 17 square, hypotenuse square minus of 8 square. That would give you 17, 289 minus of 64, which is 225, which is 15. Simple Pythagoras use we are using, right? Pythagorean's theorem. This is 15 centimeter. Is this clear to all of you? So one step we are done, right? One step we are ahead. You see, this is half 8 into BD, you can plug in now 15. In place of BD, you can put 15. But again, you require one more parameter, which is AB. So how would you find out AB? AB is again, AB would be root over of, as this is again a right angle triangle, bacho. Okay. So this you can write as 15 square minus of 9 square. Now what is this one? This is 225 minus 81, which is 144, which is on solving 12. So this is what we get is 12 centimeter. Is this clear, everyone? Now we have all the values. Let's plug in. AB is 12. This is 9. Next. This is half into 8 into what is BD? BD is given 15. No, time is not over. Why do you think? It's 5:30 only. This is not 6 o'clock. Half of, this is how much? 108 plus half of 120, which is 54 plus 60, which will give you 114. As all the lengths are given in centimeter, why you are beating? Remove it now. Thank you. No, not today, but from next week maybe. Is it 5:30? 4 to 5:30? No, I have just confirmed with the team. This is not 4 to 5:30. It is 4 to 6 for now, but probably from the next week we are planning so, right, for 4 to 5:30. Is that clear? Yes, definitely. So Silong, I think that you have done something wrong, some silly mistake, because this is not 228, but half of 228. 114 would be the correct answer. You please check, you probably have missed that half factor. Tamenglong, Silong, Itanagar, Kangpokpi, Pokpi. So tough, huh? Kangpokpi, Pokpi. Kangpokpi. Now I can take it. So, is there any doubt, anyone? Clear. Okay. Right, 114 centimeters square. Very good, very good. Let's move to other question. Next question. Okay, okay. There may be some reason. But don't worry about the timings. Don't worry about that. From the next week, definitely you will be having from 4 to 5:30 only. Okay. Next question is, in the figure ABCD is a trapezium. ABCD is a trapezium. ABCD is a trapezium given. ABCD is a trapezium given. And this is given LM. These are feet of perpendiculars. What are the lengths? Lengths are given 4 centimeter. This is 5 centimeter. This hypotenuse is given 5. Let me write here. AL is given 4. BC is given 5. This is given 7, right? 7 centimeter. AB is given 7 centimeter. This is also 5. So this is also given AD. We have to find the area of trapezium ABCD, which is quite obvious, right? We remember the formula. By applying formula, you can find it out easily. Otherwise, you can also use geometry. By the total area would be some addition of this area, then rectangle area, and then the other area. That also you can do. I'll tell you with two methods. See, method 1. Area of this quadrilateral or trapezium ABCD without using the formula, right, would be what? Actually, area of triangle ADL, right, plus area of rectangle ABLM plus of area of this triangle BMC, right? So this will be half of, anyway, can you tell me what is this length? This length would be 3. If this is 5, this is 4, this will be 3. This is also 3, this is given 7. So what is the total length? That would be 7 plus 6 is 13. So you can directly apply the formula as well, right? You please apply the formula, which is directly the answer. Half into h, which is 4, into, this is 7 plus 13. You please check out the answer. It would be 4 into, so that is 40 centimeter square. Now this is, I am doing the other way, right? If you were to add all these areas, smaller areas, so that would be half of, as this ADL and BMC both are congruent triangles, so would be having same areas, so I can make them twice. So twice of half of 3 into 4. Half into 3 into 4. area of triangle ADL, and if I multiply with 2, so that will give you this area plus of BMC area, right? Now, plus, what is this area of rectangle? That is quite obvious, 4 into 7. So this is how much? 2, 2, it cancel, and we get this 12 plus of 28, which is also 40 centimeters square. This is also called isosceles trapezium. Isosceles trapezium means these two non-parallel sides, they are also equal. Is that clear? There are two types of trapezium, guys. One is this one. Basically, one is this isosceles triangle where these two non-parallel sides, they are also equal. And the other is any kind of, right? You can take like this, or you can take something like this. So this is all rectangle. This is also trapezium, sorry, not rectangle. This is trapezium, this is also trapezium, this is also trapezium. But this is the isosceles trapezium. Why? Because sides equal. Next question is, see, questions are very easy, right? You may stuck while proving some question, but finding the areas of these, quadrilaterals would never be a difficult task. Next is, in the figure, PQRS is a parallelogram. Find the Kangpok P, what I'm saying is, what is method 2? This is method 2. Direct formula based, right? Direct formula based is method 2. Method 1 is basically by separating all the figures or by adding these areas. Find the value of y. What is the figure given? Figure is this one. This is PQRS, PQRS. This is we are given PE. This is we are given PF. Perpendicular is given F. Let me draw a different diagram. This is very messed up. Okay, P, Q, R, this is S. Now, we have this perpendicular and we have this one more perpendicular. This is, let's say, how much? This point is E, this is F. Lengths are given. This is total of 6 centimeter. This is given 3 centimeter. This SE is given. SE is given 4. QR is given 3. PQ is given 6. This is given 4 centimeter. You have to find value of Y. What is Y? QF is Y. This you have to find. Now you please find out the value of Y. Let me see how many of you will be able to solve. What is the answer? What is the value of y? What is the value of y? In the figure, PQRS is a parallelogram. I think by providing this as a parallelogram, you can easily find out the answer. It would be really difficult if this is not a regular quadrilateral or it is not any kind of parallelogram, then this problem would have been a really difficult task. But as in for the given set of data, I would say this is quite easy. Any answer? Any guesses? Wrong answers? Without attempt? Anything? Just like 1, 2, anyone, anything. Come up with the answers. Question is wrong. Yeah, that's a different answer. That's totally different answer. I did not expect this one. Okay. Okay. Fine. I was joking. Yes, that makes sense. Tamenglong, that is the correct answer. I would not say what is the correct answer, but Tamenglong has replied with the correct answer. So, any other one? Itanagar, Silong, Kangpokpi, maybe. PS is less than SC. Yeah, I got your point. It makes sense. No. Kangpokpi, I'm really happy that you observed that. It is not only about finding the answer, right? I would not say again what is Tamenglong has replied, but yes, that is the correct observation. Can you see in this diagram? If this is 3 QR, then of course PQRS being a parallelogram, this has to be 3. Is that true? So both of these sides are 3 and 3. Now, how is it possible? This will be a perpendicular when it is 3. Hypotenuse is less than SE, which is the perpendicular. So it is not possible. The data is given is not possible. So correct answer is wrong. Yes, that is the correct answer. Have you understood, everyone? I'll tell you, I'll change the figure now. Are you getting my point, everyone? This question, this data is not correct. This data is not correct. So what could possibly be correct data then? We can change it. Let me take this 8 centimeter. Right? If this is 8 now, this is also 8. This is 8. Now, what is the answer? One more time, can you find out the correct answer? Yes, Tamenglong, don't worry. That is what I was discussing now. The figure Figure is correct. Figure is correct. Don't worry. The data was not correct, right? The possible set of data was not correct, right? That was not possible actually, because you cannot take the perpendicular length higher than the hypotenuse. That's pretty obvious, right? Yeah, I have corrected it now, so don't worry. I knew it. Don't worry. I knew it that my data was incorrect. So that is the reason I have asked you to reply with the random answers. No, that is not the correct answer still. 3. No, that is not the correct answer. Seriously, is that so tough? Don't worry about the figure now, about the data. All is been corrected. Don't worry. You just have to find out the concept and you have to tell me what is the correct answer. Take your time. Okay. Now I'll show you how it would be. See, there are two ways of writing area of this parallelogram. Area of, first way, area of parallelogram PQRS would be PQRS, right? PQRS would be 6 base into height, which is 6 PQ into SE, which is how much? 6 into 4, which is 24. Is that clear? Right. Now, second way to write the area for parallelogram PQRS is also, if I were to take this base now, right, SP as the base, what would be the perpendicular? This is the perpendicular. So that is going to be SP into FQ. That is what? SP is given 8 times FQ, or which is Y, actually Y, right? So now if we are writing areas with some other orientation, the same areas with the other orientation, so area would not be changed, area would be same. 1 and 2 are equal, right? So what we get is 8 into Y equals to 24. From this Y value would be 24 by 8, which is 3. Yes, so 3, Tamenglong, my bad, Tamenglong was correct, okay? So Y equals to 3 centimeter is the correct answer. Now what Itanagar you were doing, I don't know. Itanagar, why you get 10 centimeter? This is quite a simple concept, right? We have to write down the areas in two different ways, right? And then we can compare, and we will not compare, actually we will equate them. Comparison is basically then something is lesser or greater the other thing, right? So we would be comparing, we would be equating the areas. Is that clear? Say yes, everyone, if you have understood. Yes? Let's do some question, more question. One more question is, question, if AD, this is true false type, you have to tell me what is true or false. If AD is the median of triangle ABC, if AD is the median of triangle ABC and D is the midpoint, and D is the midpoint on AC such that sorry, area of triangle ADP is to area of triangle ABD equals to 2:3, then area of triangle PDC is to area of triangle ABC equals to 1:3. Where is P point? Yes, that is what I am checking now. If AD is the median of triangle ABC, ABC, AD, ADP. Okay, question is correct. ADP. So basically there is some point C such that their areas would be divided into 2:3, right? And then you have to prove that this will be areas of PDC, right? There is some point, let's say P is somewhere here, okay? So accordingly you have to solve that area of PDC and is to ABC is to 1:3. Okay. Question is correct. You can solve this one. Well, this is quite obvious answer. You just look into the data and you will find out, okay, what is correct or not, right? Next question is, if AD is the median, let me show you a solution of it. There is a triangle ABC, ABC, of course AD does not lie on AC, na? AD is the median, right? There is some point D, let's say this is D, which is median. By joining AD, AD should be median. So these two are equal. Now if these two are equal, definitely these two are the, yes. These, okay. I understood. P is, okay, you can skip for this question, don't waste your time. I get your point, Shillong, Tamenglong, yes, right. You can do this one. I'll be checking this question. I'll give you the correct data. This resource is not that good, I would say. The median of a triangle divides it into two first triangles of equal area. Option B. You please skip this one. Like you can give it 4 or 5 lines. I will tell you the correct data. Triangles of equal area. Second is congruent triangles. This is multiple type question. C. Right angle triangles. Angled triangles. Lastly, option D is isosceles triangle. Very fast. So tell me what is the correct answer. Now with this answer, you will also realize that we were discussing about that AAS na. We can prove that median, a median will divide into two equal areas. So that you can also understand why this. What is the correct answer? Shillong, Tamenglong is saying A and A. All right. Just wait. Okay. I've got your answers. A. Nobody is saying B, C, D. This question is more than one correct type, let me tell you. One or more than one. So it may possible that you will get only one option as the correct or maybe more than one option. Think it again. Okay. Meanwhile, let me check this data. If P is the point, midpoint on AC such that this is somewhere P, let's take P is somewhere here. ADP areas, ADP and ABD. 2:3. Okay, I got it. This is not actually D. Dear students, you please make it point P. Then you can solve this question. Okay, this is not D, but this is P. Okay, this is about the previous problem, the true or false type. In the next class, you will tell me the answer, or if possible. No, it's totally fine, Temang, don't worry. Don't be so formal. It's okay. Okay. The median of a triangle divides it into two triangles of equal areas. Yes, that is definitely correct. Congruent triangles? No. Right? Temang, is it clear now? This is not correct. Right angle triangle? Definitely no. That would be one of the possible case. I mean, that would be a particular case, I would say. Isosceles triangle? No, that is not true. So only A is the correct answer. I was confusing just all of you, right? This is multiple choice question, but only one is the correct option. So is this clear? Because it can be any of scalene triangle, right? It can be of any type of the triangle. Like sides may be 5, 12, 13, a right angle one, right? Or it can be 6, 6, equilateral one, or any kind of. So in those kinds, maybe this will hold, but in general, if you have to comment on the areas, comment on the median property, then it will divide into two equal areas. That is the most correct option. Is it clear? So A is the correct answer. Now, of course, when you were to solve this as P is the midpoint on AC such that, right? Now you can solve this one. But I would say you can ignore this question because we have done a lot of this kind of problems, so you can skip it. Is it okay? It's nothing to do with the wrong question. Would be better if we do some more question which is of the correct type. No, Kang Pocky, you please think over it. This is not correct, okay? ED equals to AD, BD is equals to CD. This is not isosceles. Okay, one more time. Lastly, if this is any triangle, which we are saying that if this is the median, right? If AD is the median, this is B and C somewhere. AD is the median, then definitely areas will be equal. These two are not isosceles, right? See, when I'm saying these two are equal, na? So if these two are not equal, AD and BD are not equal, how can you say this is isosceles triangle? Yeah, I think we have discussed a lot over it. If still you have any doubt, you please ask me in the next class because this is too late now. Is it clear, everyone? Say yes or no. You guys are also exhausted, I know that, okay? So would be better if we continue in the next class then. Right? Okay. Kang Pongki, please say something. Is it good? Yes, right. Bye-bye everyone, take care and we'll see you in the next class. And once again, whatever you want me to share, like link of the previous videos or solution of the test paper or solution for assignment, just remind me. And Prashant, I'll definitely share the solution with you, so don't worry. Okay, I was busy a little. So take care everyone. We'll see you in the next class. Bye-bye.